Let us see how to solve problem on BCH decoding. So the problem given is a triple error correcting 15,5 BCH code has received a code word with two errors. So they have mentioned that there are two errors in the received code word. Although the capacity of the BCH code is uh, of correcting triple errors or three errors, but in the received code word they have mentioned that there are two errors, and the received code word is yx is equal to 1 plus x raised to 5 plus x6 plus x9 plus x raised to 10. You have to find the correct code word. So, so first thing is that you have to see what is n. N is 15. So n is 15, that means you have to use Galois field 16. So we have seen for the Galois field 16 with the primitive polynomial x raised to 4 plus x plus 1. If they have not mentioned anything, then you have to use this one only. If they have mentioned the primitive polynomial, then you have to obtain these values, and obtaining these values is very easy because we have already seen many problems on obtaining these values with the primitive polynomial. So if they have not mentioned anything, then you have to use Galois field 16 with primitive polynomial x raised to 4 plus x plus 1. Whenever n equal to 15, then you have to use Galois field 16. So we have already derived these equations for different elements of Galois field 16. That is alpha raised to 4 is equal to alpha plus 1, alpha raised to 5 is equal to alpha square plus alpha, alpha raised to 6 is alpha cube plus alpha square. All these values we have derived in one of the video, where we have the video name is, I think, construction of Galois field 16 with primitive polynomial x raised to 4 plus x plus 1. So all these we have obtained. If they have not mentioned in the exam, then you can also by heart these equations also, so that it will save your time in the exam. Okay, so this is prerequisite, this is not needed, this is not the part of the problem. So the first step for BCH decoding is finding first step is finding number of syndromes based on number of errors in the received code word. So number of errors in the received code word are 2. TC is equal to 2. That you have, that errors are there which you have to correct. So number of syndromes are 2 TC, that is equal to 4. So you have to compute S1, S2, S3, S4. So S1 is equal to Y alpha. Y alpha, that means y means received code word, this one 1 plus x5 plus x6 plus x9 plus x10. In this you have to put x equal to alpha. So 1 plus alpha raised to 5 plus alpha raised to 6 plus alpha 9 plus alpha 10. 1 plus alpha 5 is alpha square plus alpha. Then alpha 6 is alpha cube plus alpha square. Alpha 9 is alpha cube plus alpha 9 is alpha cube plus alpha. Then alpha 10 is alpha square plus alpha plus 1. After that you have to cancel out similar terms in this equation. So if you cancel out the similar terms, like alpha square is cancelled out with alpha square, same equation is written here and the similar terms are cancelled out. So remaining is only alpha square. So S1 is alpha square. Then let us find S2. S2 is, we have already seen in one of the video that SI cube is equal to SI raised to cube. That means for the syndromes in case of BCH course. So S2 we can write it as S1 square. So S2 is equal to S1 is alpha square, that is equal to alpha raised to 4. Now S3 is equal to Y alpha cube. That means in the equation of Y, this received code word, instead of x you have to put alpha cube. So 1 plus alpha cube, then alpha cube raised to 5, then alpha cube raised to 6, then alpha cube raised to 9, and alpha cube raised to 10. So 1 plus alpha cube, 5 3s are 15, 6 3s are 18, 9 3s are 27, and 10 3s are 30. After that, whenever the power goes beyond 15, you have to express it in terms of 15. So alpha 15 is 1. For Galois field 16, always alpha raised to 15 is equal to 1. Then alpha 18 is alpha 15 into alpha raised to 3. Alpha 27 is alpha 15 into alpha raised to 12. Alpha 30 is alpha 15 into alpha 15. Why we are expressing in terms of alpha 15? Because alpha 15 is equal to 1. So 1 plus alpha cube plus 1 plus 1 into alpha cube plus 1 into alpha raised to 12 plus 1 into 1. So 1 plus alpha cube plus 1 plus alpha cube, alpha 12 is equal to, where is that? Okay. Alpha cube plus alpha square plus alpha plus 1. So that is written here, alpha cube plus alpha square plus alpha plus 1. So after that, similar terms are cancelled out, like alpha cube 1 1. Then here 1 1. Remaining is alpha cube plus alpha square plus alpha. So that is equal to alpha 11. So alpha 11. Now S4 is S2 square. S2 is alpha 4. Alpha 4 square is alpha 8. So this is step 1. We have computed the syndromes. After that, step 2 is compute matrix M. So matrix M is equal to S1, S2, S2, S3. When there are 2 errors in the received code word. So S1, S2, S2, S3. So how to remember this? See, so this is 1 less than S4 or 2 TC. So S3. So put the values. So that is alpha square, alpha raised to 4, alpha raised to 4, alpha raised to 11. S3 is alpha raised to 11. Now you have to find mod M. Mod M is this and this multiplication. Alpha 11 into alpha 2 minus we don't use for mod for binary case we use plus. So plus alpha 4 into alpha 4. Mod you compute it as like this minus this, but instead of minus write plus because it is a XOR operation or binary operation. So 11 into 2, that is equal to 13. 11 plus 2. So 4 plus 4, 8. 13 is equal to alpha cube plus alpha square plus 1. Alpha 13. Alpha cube plus alpha square plus 1. Then alpha 8. Alpha 8 is equal to alpha square plus 1. So similar terms, alpha square 1 gets cancelled out. Remaining is alpha cube. So mod M is not equal to 0. So it is non-singular. So find M inverse. So you can find the inverse of matrix M. So inverse of matrix M is 1 by mod M, and you have to take the cofactors of M. So for that, a simple trick is that this is 1 by alpha cube is mod M. This is alpha cube. Then you have to take alpha 11 here and alpha 2 here, and you have to exchange this. So 11, 2, 4, 4. So 4, 4 is same. That's why it is remains same. After that, you have to divide it with alpha cube. Alpha 11 by alpha cube, alpha 4 by alpha cube, alpha 4 by alpha cube, alpha square by alpha cube. So that is equal to 8. And this is 1 alpha. This is alpha. This is 1 by alpha. So after that, 1 by alpha. Instead of 1, write alpha 15. 1 is alpha 15. So that becomes alpha 14. So you got the alpha M inverse. That is inverse of matrix M. Step 3 is find error vector. You have to find the error vector. For that you have to use the equation lambda 2 lambda 1 is equal to this M inverse. So this is M inverse. No? I have written it as M. So this is M inverse. M inverse S3 S4. So here you have to start from TC plus 1, TC plus 2. So TC plus 1 is 2 plus 1, 3, 4. So S3, S4. This you have to by heart. So lambda 2, lambda 1 is equal to M inverse S3, S4. So just 2, 3 key points you can remember that here there is 2 TC. So TC is 2, so 4. So 3, 4. So write down M inverse alpha 8 alpha 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 raised to 14. S3 is alpha 11. S4 is alpha 8. S3 is alpha 11. Yes, S3 is alpha 11. S4 is alpha 8. After that you have to do this multiplication. You know how to do the multiplication. You have to multiply alpha 8 with alpha 11, this and this, na, alpha 8 alpha 11, alpha into alpha 8, then alpha into alpha 11 plus alpha 14 into alpha 8. So alpha 11 into alpha 8 is alpha 19, alpha into alpha 8 is alpha 9, alpha into alpha 11 is alpha 12, alpha 14 plus 8 is 22. Then 19 is expressed as 15 into 4, then 9, 12, 22 is 15 into 7, alpha 15 into alpha 7, because we have to express whenever it goes beyond 15 you have to express it in terms of alpha raised to 15. Then this is alpha 4 because alpha 15 is 1 plus alpha 9, alpha 12, alpha 15 is 1, alpha 7. Now alpha 4 is alpha plus 1, alpha 9 is alpha cube plus alpha, alpha 12 is alpha cube plus alpha square plus alpha plus 1. So these values are already discussed here. Alpha 12 is alpha cube plus alpha square plus alpha plus 1. This is prerequisite. Then alpha 7 is alpha cube plus alpha plus 1. Alpha 7 is alpha cube plus alpha plus 1. Then alpha 4 is alpha plus 1. Alpha 9 is alpha cube plus alpha. So similar terms gets cancelled out. Alpha gets cancelled out. So alpha cube plus 1. And here remaining is only alpha square, because others gets cancelled out. Alpha cube, alpha plus 1, alpha plus 1. So alpha cube plus 1 is equal to alpha 14. Alpha 14 is alpha cube plus 1. So lambda 2, lambda 1 is alpha 14. So this is nothing but, this multiplication is nothing but lambda 2, lambda 1. So lambda 2, lambda 1 is alpha 14, alpha square. So you have to express it in terms of lambda equation. So that is lambda x is equal to 1 plus this lambda 1. This is lambda 1. 1 plus alpha square x plus alpha 14 x square. So alpha square x plus alpha 14 x square. After that, this is you have to solve this equation, quadratic equation. For that you have to what is the clue? You have to express alpha 14 in such a way that its addition will be alpha square. So you have to do trial and error. So alpha 14 is nothing but, if you try, alpha 14 is alpha 10 into alpha 4. If you try this one, alpha 10 into alpha 4, then you have to see whether alpha 10 plus alpha 4 is equal to alpha square. You have to see whether alpha 10 plus alpha 4 is equal to alpha square. So alpha 10 is equal to alpha square plus alpha plus 1. Alpha 10 and alpha 4 is alpha plus 1. So alpha plus 1 and alpha plus 1. So alpha 10 is this, alpha 4 is this. If you add these two, then you will get alpha square. So here only you will get the answer, that alpha 14 is expressed as alpha 10 into alpha 4, that is equal to 10 plus 4 is 14, and its addition alpha 10 plus alpha 4 is equal to alpha square. So you have to express alpha 14 in two product terms such that their addition will be alpha square. Here after that there is no need to solve this actually, because it will increase the length of the problem. So here only you will get alpha 10 and alpha 4. So alpha 10 and alpha 4 are the error location points. So you have to write directly, you can write Ex is equal to x raised to 4 plus x raised to 10. So if you don't solve this now, then also it is okay. This is lambda x. So Ex will you can write it like this, that 1 plus alpha raised to 10x plus alpha 4x is equal to, this alpha square is alpha 10x plus alpha 4x. Alpha 14 is alpha 10 into alpha 4x. So here only you can write Ex as x raised to 4 plus x raised to 10. So I feel it is not needed to solve, because it will increase the length of the problem. So here you have written alpha square as alpha 10x plus alpha 4x and alpha 14 as alpha 10 into alpha 4. So you have to take alpha, for alpha 10 you have to write x10, for alpha 4 you have to write x4. So Ex is x4 plus x10. So Cx, corrected code word is Yx plus Ex. Yx is 1 plus x plus x5 plus x6 plus x9 plus x10. So Yx is here, they have given this Yx. you have to add this ex is x4 plus x10, x4 plus x10, x10 gets cancelled out, so corrected code is 1 plus x plus x4 plus x5 plus x6 plus x9. So this is the problem on BCH decoding. Hope you understood this problem.